the plan for today? The plan for today is 1, we need to talk a bit about the midterm. 2, I need to answer questions related to Lab 5 if you have any. 3, I need to show you the schedule and start with Lab 4. Okay, concerning the midterm, I had a talk with the Monday section yesterday, and I didn't have the chance to talk to you yet. It's impossible to do the lab on the 20 for many reasons, and one of the most important reason is it's too early for many. Which means the other sections, not us, they suggested 27 وطلعت الصرخة لأنه on the 27 that is a Saturday many students have a lot. So I pushed it for the 29. I know 29 is not great, especially for the students who have an exam on the 30, but it was an alternative because I suppose it's better than the 27. Okay, so yes, the midterm is going to happen on the 29, which is a Monday in the evening. I know it's not ideal, I know it's not the best, but we need to have a date for us to plan accordingly. It's wrong to keep it hanging like this. Okay, it had to be postponed for many reasons beyond my control. This is one thing. Another thing you need to know, and I think you have enough time to adapt and to think about it, that we have no choice. We have to open responders, and therefore we cannot use Excel for the midterm. What does this mean? It means many things. 1, for you to find the slope, only the slope itself, you have to know how to do it on the calculator. And I think it will not take you more than Excel, because anyway, on Excel, you have to plot first and then find the equation. On the calculator, you have to put the values in a table and find the slope. So probably it's the same timing. It's only that you need to try it once to see how it works. Concerning the RMS, you're doing it on the calculator anyway, you cannot do it on Excel. Concerning the propagation of error, you're doing it on the calculator anyway, you cannot do it on Excel. Concerning the error on the slope, you need Excel anyway, because the Linus method is great, it takes 1 second. Although 20% of the students don't know how to use it well yet. And anyway, you need an Excel spreadsheet to drag and do the calculation. So probably not included in the midterm would solve the issue, you know? And if the midterm is a multiple choice, and I will confirm that by next week, definitely, in most of the cases, you don't even need to do the calculation. You can guess, because many of the answers you have in the multiple choices would be definitely obviously wrong. You see what I mean? In many of the previous midterms we gave, you can pick the right answer without doing the calculation, because many answers given are not possible, you know? So if they ever give you the average and the RMS, you can have an idea, like guess what the average is and what the RMS is, or probably guess which ones are wrong. Sometimes the wrong thing is the unit. Sometimes the rounding is the wrong thing. So if you can cross out D and C and B, you know the answer is A without doing any calculation. So, and obviously if you guys, now this is a second thing I need to discuss. If you guys are doing your lab reports, I don't see why you need to study for a midterm. This is for the students who are stressing over the fact that they have a lot of exams happening before the midterm and after the midterm. Okay, so organize yourself and please don't stress about it. I'm assuming you're doing those lab reports and nobody else, okay? Any comments before I talk about something else? All right, now yes, go ahead, Giscard.
Sorry.
I know you have an exam on the 30th, yes, I remember.
How do the questions of the midterm look like?
All right.
Are they exercises? Are they,
all right.
I don't know,
all right.
problem solving?
I can tell you 90% it's gonna be multiple choice. I'm not sure though. Multiple choice means, let's say you're gonna be given 20 questions. The duration, I don't know, probably 30 minutes. All right, so I'm telling you from now, it's gonna be a very quick exam. You have to be fast, probably. 2, you will be asked a lot of data analysis questions and a lot of conceptual questions, no problem solving. Data analysis means you will be given data, you need to find the slope. You are given data, you have to find the average RMS. All right. So Gael, I will email everybody tonight to say it's the Monday 29, 7 p.m. Exactly what I wrote on WhatsApp yesterday. Okay. I couldn't find an alternative. By the way, yes, I know, Gael. I know 29 is not the best day, but it's better than many other dates. So if you know the date from now, probably you can organize yourself. Okay. Yes, I was pushing for 27 until I realized it's a nightmare for more than 80% of the students. Okay. So let me say it again. So back to you, Giscard. So a lot of data analysis questions sometimes, and when I say conceptual questions, what I mean is the following: you need to discuss, for example, the behavior of projectile motion, of the range, of and it's gonna be multiple choice. So if I'm gonna ask you to sketch something, I will give you 4 sketches to pick from. You see what I mean? And let's say I tell you, I will double or triple, I don't know, a certain variable. What happens to the other variable? Or probably I can give you, I don't know, some scenario and give you 4 options to pick from. Not something like the course where you need to calculate. You see what I mean by conceptual questions? By the way, in each and every lab report, you have conceptual questions. Let me show you to tell you what I mean. I'm gonna show you simply just a second. I think I need to update my.
Doctor, should we like explain on the scratch?
No, it's gonna be quick, multiple choice, randomized. So you will have different questions, and respond is open. So you're gonna do your best to finish it. Okay. Let me show you the first lab report. Okay, so for what launching angle would you expect a maximum range? This is a conceptual question. What should you do to increase? This is a conceptual question, you see, and you will be given only one answer that is right. I doubt, Mia, we are gonna give you a problem to solve. And the reason is because you're too many. I think you are 6 sections. All right. We sometimes do that where the students are given a 20% of the grade where they have a tiny problem to solve on a paper to scan and upload. But I think we're not going to do that. But by next Tuesday, I can confirm. Okay. Yeah. I suppose you know how to.
I tried chemistry yesterday. It was so time consuming and everyone was not able to upload. يعني اعطونا 5 minutes ما حدا لحق ال 5 minutes scanning لأنه the Wi-Fi is so slow.
Yeah, and I know you are not trained well to do it. Like my kids in grade 5, they do it better than you, not because you're stupid or something, but because they are trained to do it. And I remember last semester I had an issue with this, students not knowing how to scan. They take pictures, huge size, to send it you need forever. So I know you're not trained to do that, and I did not train you to do that. So I would be worried about it, and I know we're gonna have an issue. And if I ever need to do that, probably I need to train you a week ahead. Some students in your section probably don't have the appropriate app to do it. And if you're gonna have to do that in some other courses, not the physics lab, I'm talking about chemistry, bio, what, anything, please train yourself to know which app to use and how to scan to have a file that is tiny in size. And make sure you upload one file and not multiple pictures. Yes, I know, but trust me, Mia and Gael and all the people who are laughing, you guys are so much better than the students we had previously. At least you had, I don't know, online learning last semester. They never had it before, so I totally understand what they're going through. All right, so yes. Now, shall we move to lab 5? Do you have any questions? I believe you were doing lab 5. You have it for this week, right? It's not tough though, unless you have a question that is not clear. So any questions related to the midterm? You can ask me anything you remember later if you want. Shall we go to simple harmonic motion? How was it? Did you start? You have issues? Nothing? You guys are fine?
Doctor?
Yes, Zilla?
I just have a small question in part D.
Yeah.
So in question 2, part B, you want us to plot the graph with the error bars. On Excel, I tried to plot to the error bars, but there were two types.
Listen, remove the error bar idea. I never told you how to do it, and this question was in the lab report. However, I did this manual, but I did not see it. Another student asked me about it. It's optional. You want to do it? Do it. You don't want to do it? Don't do it. I never told you how to do it. I never trained you to do it. So, and it shouldn't matter because the error on the slope will not be related to them. The error bars usually are done in IB, for example, because they use them to find the slope and the ranges of the slope and to find the error on the slope. But in your case, you're finding the error on the slope irrespective, using a different method. So if you do the error bars or not, it's only visual, and they're not going to be used in a quantitative way to find the error in the future. You see? And I'm sorry for this question. I did not see it. Otherwise, I would remove it.
Okay, and another question in question 4, where we have to plot with the displacement and the time, do we choose random numbers, or is there any specific numbers you want us to choose?
All right, let me be clear on this level. Sketch is not a plot. We asked you to sketch because we want a description and we want to see how the graph looks like. We want you to describe the graph. We don't want you to have some points and to plot. I had an issue with Physics 306, not your class, where I gave, they had a certain graph that looks weird, and they took only 3 points to do the analysis. They were required to do that. And then we asked them to sketch it by simply looking at the experiment and draw what they see, description. They plot using the 3 points, and 3 points will give you a tiny curve, but however, they had something like a butterfly. You see? So sketch means show the whole behavior. It doesn't mean plot and create random values to plot. Sketch it with a pencil, it's okay. So sketch means show the general behavior. In any case, because to sketch the displacement time graph, probably the displacement is going to start from 0 or from displacement max, which doesn't matter. We want to see how the amplitude is going to behave with or without damping, and probably the period with and without damping, you see? So sketch, let it be with a pencil. And I know a lot of students don't like to use pencil because they want a very tiny lab report. If you want that and you can find a sketch online with a reference, why not? But don't plot, please, because plot means you're creating a scenario that may not be real. You see? Don't fake it.
Thank you so much, Doctor.
And sketch means description. It doesn't mean quantitative description. You see? بس the shape يعني. Curve, straight line, ما بعرف damping, show the damping. Yeah? All right. Any other question related to lab 5? I need to ask you to put your cameras on if you can and for a short while, because I would love to see you. Okay? Thank you so much.
I have a small question.
Yes.
For the graphs, do you want us, like the previous report, to plot the points without the line and then we add the best fit, or do we plot the points with the line connecting them?
All right, I don't remember saying anything about that, but I can tell you what's ideal. It's very important to show the measurements, in other words, the points, and it's very important to show the best fit line, and you can do them together on one graph. No need to show 2 separate graphs. Don't show the best fit without the points. That's something I know for sure. And don't show a line connecting the points because it doesn't make sense. Just the points, because this is what's given, and the best fit. And together on one graph is enough. No need to separate them. And please, I'm just saying about what I'm seeing through your lab reports, not your section, all sections. And please don't do the graph on a squared paper. If you want to do it on a graph paper, I'm okay with it. But squared paper, I mean any random math notebook, please don't do that, okay? Many students, more than 2, are doing it on a random paper from any notebook, It's not precise at all, and it will not serve any data analysis. Use Excel as much as you want, even if it's not for the midterm. It's okay. I want you to be well trained on Excel because that's the future of data analysis anyway, not the calculator itself. And the midterm, remember, is nothing but like 20% of the whole time you waste doing the work, right? Probably waste is not the appropriate word, like you spend doing the work. So it's okay if a midterm of 20 minutes, use the calculator. But learning skills on Excel will stay with you for other labs to come, you see? So I don't see هيدا بس جواب اللي سألوني أنه لشو عم نتعلم إكسل إذا ما في بالميدترم. لا، عم نتعلمه لأنه منعوزه ولأنه مهم نتعلمه. نحن مش عم نشتغل للميدترم. Okay? And it's okay if we know how to do stuff on the calculator. مش أنه بنلغي إكسل. لا، إكسل أهم من الميدترم. Yes. Any questions related to lab 5? Thank you for those questions. I love them. Ask me more, please. All right. Let me show you the schedule before we proceed. So we basically did 1, 2, 3, and 5. And yes, 1, 2, 3, and 5 are for the midterm. Calculate the slope, Gael. You already have, it's on the calculator. No access to Excel because we cannot move to Excel because of respondus. And I need to tell you that the time taken to do the work on the calculator or on Excel is basically the same, but you need to make sure you know how to do it. You already have a link on your Blackboard on how to calculate the slope on a calculator, I suppose. I hope you saw it. You just need to see where to put the points, click linear regression, click slope, that's it. But you have to put the points in the table. And I suppose you're doing that on Excel anyway. On Excel, you put the points in a table and you plot and then you add equation, right? So probably more work. So it's good to do it on a calculator. It's not like more time consuming. Okay? I know that your class is okay with it, but some other sections with other instructors, they never did it. And that's the issue. You're fine. Probably you're not using it. Do it once. If you want, write the method on a note paper. Okay, now I want us to do lab 4, even though the Monday section did lab 7 and yesterday they did lab 4. So it's okay if we follow them and we do lab 7 whenever they will be on a holiday for Monday, Easter Monday. So lab 4 is the one we're gonna do today. It's still fresh on my desktop anyway. And those videos were recorded yesterday. And I'm so happy about that, by the way. All right, momentum and collision. And I'm also always proud to follow the order because for the students who are taking the course at the same time with the lab during the same semester, it's always healthier to follow the order because that's what's happening in the course as well, I suppose. However, don't forget that all this is related to high school material. So you don't really need the course. The lab is supposed to be introductory to the course. The outline I will follow is what's linear momentum, and then the impulse momentum theorem. I know that the title says collision, but we're not gonna do collision of two objects where the objects are gonna rebound. We're gonna do collision of an object with a wall. So I'm gonna study only one system, the momentum of which is changing due to a force happening over a certain time. And this is what I mean by the impulse momentum theorem. What is impulse and how it is related to force applied to the system and the time of the collision. I will discuss the experiment, like which tools I use, which sensors, and so on. Then I'm going to discuss two ideas, or basically three ideas. They are basically two ideas, conceptual applications for the impulse momentum theorem, and they are related to some questions in the lab report. I didn't want to leave you alone to think about them, probably discuss them a bit together, and wrap up the two examples with a general understanding of abrupt and cushioned collisions. What's the difference between an abrupt collision and a cushioned collision, and probably discuss safety in general, okay? Linear momentum, what is it? Do you remember? What's linear momentum? MV. Why do we care about linear momentum? Isn't kinetic energy enough? It's related to MMV as well. Why study linear momentum if we have kinetic energy? Nobody knows. Is it a scalar or a vector? I know kinetic energy is a scalar. What about momentum? Momentum is a vector. Yes. You want to say something? George or probably Giscard? All right. Anyway.
No, I said vector.
Oh, vector. Yes, I heard something. So basically, let me move those to the side. Yes, momentum is m times v. And by the way, bold means a vector in many books. Okay, I'm gonna remove this one. Okay, momentum is m times v. We actually need it on top of kinetic energy because it represents a quantity that is easily transferable between two systems. Every time two systems collide, system 1 will give momentum, linear momentum to system 2, or takes linear momentum from system 2. Unlike kinetic energy, which is not always transferable, okay? Especially that momentum has information about the magnitude of it and the vector of it. And you know the vector is important during collision because you can predict the direction of the motion before or after collision, okay? Anyone remembers the unit of linear momentum? No one?
Kilogram per second squared.
Why second squared?
Per second, sorry.
Yeah, kilogram dot meter per second. Right, very easy to find the linear momentum of any object if you have the mass and the speed. Now, impulse momentum theorem. Let me start by discussing what impulse is. Impulse, by definition, is the change in momentum. And change in momentum can be written as delta momentum, which is momentum final minus momentum initial, like any change in temperature, change in mass, change in time. It's always final minus initial. Now I'm going to start from Newton's second law. Do you remember what is Newton's second law? Or how about I tell you what is Newton's second law, because I know you remember. George, you said MA. Who is MA? Clara, you said F equals MA. Which F? Zilla is saying sigma F. All right, how about we say the sigma F external, like the net external force is equal to MA. So this is the net external force is equal to M times A. And A is the derivative of V with respect to time, okay? Or the change in V with respect to time, or the rate of which the velocity is changing, and you see the vector. Now, if I put the M inside the derivative, I will have dmv over dt or dp over dt. This is the impulse momentum theorem. So as you can see, it's nothing but Newton's second law written differently. Now, in most of the problems you do in the course, the acceleration is constant. In most of them, not all of them, but you never study a change in acceleration unless you do simple harmonic motion. But usually acceleration is a constant. And when you do all the kinematics equation, they can only be used at constant acceleration, right? So acceleration constant means that instead of saying dv over dt, I can say delta v over delta t or delta p over delta t. So this equation can be written as such only if the increase or the decrease is linear. Okay, you can write it also like that. And I love the fact to write it down like this because I can translate it into words by saying the change in momentum is due to a certain force applied over a certain time. And I need to be careful about time. Time is not the time before collision. It's time during the collision, which is usually a fraction of a second. When I clap and I have two hands hitting each other, what is the time of the collision? It's so short. This is the time I'm talking about. It's not the time before they hit. It's the time during which they touch each other, which is a fraction of a second. And I know for a fact that intuitively as a human, you use this time, for example, to catch something. If you want to catch a ball, you never catch a ball like this. You go with it a bit. If you want to play basketball and you want to throw it, you take your hand back and you give it time, you know. When you play tennis, you know, the racket is elastic in a way. So the tennis ball will touch the racket and it's gonna go a bit back and then forward. So the time is elongated a bit to increase the impulse or the change in the momentum required. Okay, remember, and you're gonna do mistakes today, which is okay. I want you to do those mistakes. Time during the collision, not before collision. Okay? Now I have issues. How do I calculate delta P? And definitely we're gonna discuss it, but probably talk a bit about it. Delta P can be P final minus P initial. Some people would say MV final. Yes, thank you, Zilla, minus MV initial. Some people would want to say it's F delta T, or it's the area under an FT graph if F is not a constant. So in other words, it's going to be the integral of F delta T, which is the area under the curve. If F is a constant, or you can simply talk about the average force, you can do F delta T. And I'm going to get back to this one. Now the experiment, let me start with how the setup looks like, who's doing the measurements, which sensors, and then what do I measure, and to go back to the impulse momentum theorem, okay? This is a general picture of something I had ready before going to the lab. In the next slide, I'm gonna give you what we have. I'm gonna show you what we have in the lab. This is a track inclined with a certain angle. I don't need to incline the track. Am I disconnected? No. I can simply push the cart with my hand. But if I create a constant angle, I would know what the acceleration is. It's g sine alpha. And I can start always with the same acceleration, same position, and therefore same speed before the collision. And every time I have variables in my experiment, I always would like to have so many constants to be able to focus on the variable and the effect of the variable on my setup, you know? So if I can have a constant acceleration for all my trials, why not? That's why I did an incline. You can see a motion sensor, and by now you know a bit what we use it for. And this cart is gonna collide with an obstacle, but before it collides with an obstacle, it's smart if we put a force sensor between the obstacle and the cart to measure the force of the impact. All right, so now we have a motion sensor, and the new sensor is a force sensor. I need somebody to remind me how the motion sensor functions. Anything you remember, even if it's random. How does it function? Does it need calibration? Does it need zeroing? What does it send? What does it receive? What does it give eventually through Data Studio? What kind of data? What kind of force, time? What does it give? Try. I'm all ears. Clara is saying that the motion sensor sends ultrasounds. And how do we believe I can use those ultrasounds? They hit the cord and they come back to the motion sensor. So the motion sensor will receive back the ultrasounds. So the motion sensor can measure the time taken to the ultrasound to go and come back. It will record the T. Knowing the speed of the sound that is known at regular temperature, we can tell the distance of the card. Now that the distance is changing because ultrasounds are being sent all the time continuously, you can see a distance constant or changing. You can plot X versus time, and then V versus time, and then A versus time. Yes, George. So the motion sensor will give you XT, VT, and AT graphs. Every time you want XT, VT, AT, you grab a motion sensor. Does it need calibration, zeroing, any special something? No, you just need to make sure that the speed of sound is known and it's in the setup, and this is something you don't do on a daily basis, like you do it once. I don't call this calibration, it's not worth it. So user-friendly, very nice to handle. ما بينتزعوا بيعقدوا motion sensors. I'm still using motion sensors from the lab, and I had them before 2006, like they're older than me. Yes. Now force sensors are new to us, to you, not to us. They're very sensitive, they're not user-friendly, and personally, I don't like them at all, because as an instructor, they give me a lot of hard time. Other than the fact that they're very sensitive وبينتزعوا 100,000 خبرية, one, they need to be calibrated لأنه they don't measure newtons, they measure volts. They have a capacitor inside, and every time you pull or push on the trigger, they measure a certain voltage. And every morning, I need to apply a known force, like a weight, and measure the volts, and write inside the setup, this volts is equivalent to this amount of Newton. And then when you can use it, automatically, since it's linear, the app or the software will calculate this Newton is how many, this volts is how many Newtons. So as an instructor myself, I have to calibrate every time you come to the lab, every single morning and every single bench. This is one. Two, every time you need to take a trial, you have to zero the force sensor. It has a zero button, like a tear button. Because every time you take a measurement, the measurement stays inside. Isn't it a capacitor that you're charging? You have to empty the capacitor before every single measurement. Every single measurement. And if you forget, it adds up to the old one. So مزعج anyway. It's not user-friendly. But this is the most accurate thing we can have. All force sensors are like this, in other words. All right, now let me show you the actual real picture. This is my hand. This is the track. It has a height from one side, and you can see this again in the video. I have an angle. The angle is not a variable, which means the angle is a constant. So the protractor is here for me to make sure all the time that the angle is constant, because I'm scared every time collision happens, the track is gonna slide a bit and change the angle a bit. So I'm gonna keep it constant. However, if the track slides and the angle changes, I will not have any error, because the experiment is not going to be affected. It's only like my constant may change a bit, so it will be more difficult for me to analyze my results. But it's not like the impulse is going to be wrong. Collision is going to happen, and the speed before and after is going to be measured, and the force is going to be measured along with the time. But it's better for me to keep it constant if I can, just for me to understand what happened. And this is the cord going down the incline, hitting the force sensor. Okay, this is the force sensor. And this is, again, I'm gonna do F delta T. So this would be measured, you tell me, by the force sensor or the motion sensor? F delta T. Who would measure F delta T, the force sensor or the motion sensor? Yes? Yes, obviously the force sensor. So the force sensor is gonna give me an FT graph, and the area of the FT graph is gonna be F delta T. So this is given by the force sensor. However, the MV final minus MV initial will be measured using a VT graph. On the VT graph, I can see V before collision, V after collision, and this is measured by the motion sensor. Okay, so I need to compare this value and this value, and both are experimental values. How do I compare two values? I do the percentage difference, but usually I compare experimental to theoretical. Today you're gonna compare experimental to experimental, and you're gonna be angry about it because you're gonna ask me which one is the reference, and both are experimental. You will pick the reference you want. If they are very close to each other, it shouldn't matter really. Okay, and I mean by reference, how do we find the percentage error? Because we do experimental minus theoretical over theoretical. The theoretical is the reference. Now you're gonna do experimental 1 minus experimental 2 over, you pick one to be your reference. It doesn't matter if they're close. All right, definitely the percentage difference is gonna change a bit, but it will be obvious if it's accurate or not. Okay, yes, I'm talking about the denominator. All right, now back to our measurements. This is what you will see. This is the VT graph given by the motion sensor. This is the FT graph given by the force sensor. Let me explain, and let me not forget to save as our presentation, your class only. Okay, so you can see that as the cord is going down the incline, it's gonna speed up, and let me zoom in. It's gonna speed up until suddenly it collides with the obstacle, and you see a sudden change in the velocity. It's positive, it becomes negative. This is going down the incline as positive, then suddenly it's going up the incline, slowing down to a stop, and this is where the stop is. The sudden change in direction is due to the collision, and it's wrong to say sudden, because if you think about it, it's happening over a time interval that is not zero. So sudden means 0 time interval. The time interval is so tiny, less than 1 second, but not 0 yet. You see? So it's not so sudden if you think about it. This is called V initial or V before collision. And this is called V after collision or V final, whatever you want to call it. You simply need to know the Y component of this point and the Y component of this point, knowing that the X component is T1 and the X component is T2. All right? Any smart tool, you can see the coordinates on the graph. Now the force before collision, it's 0. At collision, it's gonna go so high, then nothing again. All right? So no collision, collision, then nothing. You're not gonna see a white peak like this one. It's gonna be so sharp. This is zoomed in because you can see this is 0.1 second. Can you imagine how small this time is? This is 0.2 second. Nobody can feel 0.2 seconds. This is zoomed in. That's why you can see what you have under the curve. So the area here, the area A, is nothing but the integral of f delta t or f dt. And this is equal to P final minus P initial or MV final minus MV initial. So MV final minus MV initial will be found from the first graph, and the area is gonna be found from the second graph. And you're gonna compare this one to this one. Supposedly they should be very close, okay? Now let me show you real pictures. This is a real picture of the V, like taken from the experiment I did yesterday. Speeding up while going down the incline, then suddenly collision, and then going up. And you can see, going up, I mean slowing down to a stop. And you can see the smart tool giving me coordinates. And yes, the velocity is gonna become negative. On the other side, the force sensor is gonna give you a negative force because for my sensor, this is how I calibrated it. I wrote that it's a push force is negative, pull force is the positive. And it's okay because you're gonna do final minus initial for velocity. The final impulse is gonna be negative. So if the area is negative, why not? So you see 0 force because I zeroed my force sensor and I'm proud of this 0. If it's not 0, it means there's something wrong. Then you have collision, then 0 again. And this is the area under the curve. It will be more visible on the video. Okay, this is the area under the curve. It's a negative area. It's okay because this is gonna be negative. By the way, negative means direction, opposite to motion. And the force is opposite to the motion because you're colliding with the wall. The wall is gonna push you back. This is the table you need to fill. By the way, you need to add mass to your cart for each trial. This is your only variable. So this is the actual cart with no mass. Then you add mass, then you add mass, then you add mass, you add mass. This is the area under the curve. It will be given to you for all trials. I'm gonna start for every trial from the same position, same angle, because I want V before collision to be a constant, if possible. I know friction is not gonna give me a perfectly constant V before, but it's okay, especially then when I add more mass. In other words, friction is gonna increase probably, okay? Because the heavier, the more normal force, and eventually mu times n friction is gonna be probably different. V before, V after is gonna be given from the VT graph. P before, P after should be calculated by simply multiplying by the mass. Delta P is calculated as P after minus P before, or P final minus P initial. Percentage difference here will be simply doing delta P and the impulse, comparing them, okay? The impulse is the area or from the force sensor. Delta P is MV final minus MV initial from the VT graph, which is the motion sensor. So one measured by the force sensor, one measured by the motion sensor. It's as if I'm comparing two sensors, okay? What else? All right, let me show you the videos before I discuss the egg drop and all this, okay? This is the first video, or this, I don't know, probably this is the first video. By the way, I changed the videos a bit. I asked Miss Jinan to take the recording for me. So she used her phone, probably much better than my phone, and no tripod, which means the camera is moving with me, which is bad anyway, but also good to zoom in for certain things for you to see, okay? So I suppose it's better than the old videos I did the previous semesters. So in this part, okay, let me fast forward. In this part, just a second, I'm too fast for you. All right, so I will start from the beginning. I'm explaining how the track is. I'm explaining what equipment you have. I'm showing you the track, how smooth. I'm showing you the motion sensor, just a reminder on how it functions, what it is, what it's gonna do, how user-friendly it is. And you see the camera zooming into it. Yes, it's funny. And then you see the angle, the protractor. Probably you can have a look at the precision. However, it's not needed. I'm showing you how I change the height, but I'm gonna keep it constant. This is the chord, and you can see the mass. It's a digital measuring tool. You can hear me saying it. Okay, and then it's gonna collide with the force sensor. So this is the force sensor. I'm showing you how it looks like. Probably I'm going a bit fast for your eyes. I'm showing you that it has a bumper. I can remove the bumper, put a hook. It can measure push or pull. I'm explaining how I calibrate. I'm also explaining where's the tear button or the push button. You're gonna see the push button here. You see it on the right. Definitely you can watch the video again slowly. Okay, I'm gonna push the tear button for 10 seconds to make sure it's zeroed. I'm gonna put it here. I will make sure it's aligned with the bumper of the cart before collision happens. Okay, sometimes the force sensor is a bit not aligned with the cart, which means collision is not gonna be perfect. Okay, you can see it.
The incline, for it not to happen, and the force sensor for every time collision is gonna occur. Also, it's very important when I...
All right, you see collision is not so fast because I picked a very small angle. Very fast collisions are not advised because otherwise you're gonna lose the cart out of the track, or probably the force sensor is gonna move a bit. So let's not be extreme, okay? The cart is very fast and the track is very smooth. No need for high angles to observe a very nice motion, okay? That's the first video, now getting ready with the experiment. The second video is to show you what I did as measurements, okay? And yes, I will show you how things are. Like here, I showed you where I start from. You can see the mouse is under the cart because I don't want to put my hand on top of the cart and disturb the motion, okay? So I will click on record while I release the cart. I don't have to be simultaneous, but it's important to stop after the first collision. So whenever you see collision, stop it. Otherwise, it's gonna record 2 collisions in a row and give me the area for 2 peaks. And I don't want this to happen. This is one measurement I did. Okay, let me show you.
A bit, let me...
Okay, 1 second. Let me move back because yeah.
Okay, so I clicked stop directly after the collision. I did not wait for a second.
All right, so here you can see the FT graph and the VT graph, and I'm explaining the VT graph a bit, how you have increase and then sudden change and velocity, then decrease as you slow down. And you can see the smart tool to find the Y components of the points before and after collision. You can also see the X component, which is the time, and calculate the delta T if you want. When you can see the area under the curve, and you can zoom in to see what's inside, and you can see the area. Let me see if the area is visible. Just a second. Area.
Zoom in the x-axis a bit. Let me try. And the y-axis a bit so you can see. I'm very happy to see a perfect zero. This shows that
all right, enough with showing off with my force sensor being on 0.
To the experiment. Sometimes when you don't, it will show that the Data Studio will actually help you by finding the area under the curve. In this case, you can read -0.25 Newton second.
All right, the unit is very important. Newton second is nothing but kilogram meter per second, right? So this is F delta T, that's why it's Newton second, or delta P, which is the same unit. So basically what I'm gonna show you here, that I'm gonna add a mass, and this is the mass I'm talking about. Where is it? You see the mass?
An extra mass to my system. I will keep everything else fixed, the angle fixed.
All right, so I'm explaining all the constant, the only variable is the mass. I will repeat the collision and do the measurement again and explain everything, so on and so forth. So that's it, and you can watch the videos later. Mia, you're good? You're laughing about which part? I did not see it. All right. So now We're ready to start with some conceptual questions related to the egg drop contest. All right. So I need to discuss the egg drop contest for many reasons. One, I find it very interesting. Two, it's an international competition happening around the world, so it's good to hear about it a bit. During my life at LAU, I think they did it once or twice. It was the engineering department. It was sponsored by Red Bull, if I'm not wrong. And the height, okay, let me tell you a bit about the project. You need to throw a raw egg. Did you ever do that? Did that in school? The egg drop contest? Or probably you are the Corona generation, you never went to school. Mia, can you tell me a bit about your experience? Yes, George, I think that's it. What did you do, Mia? You have it in school?
Yes, أنا وجيال we did it.
Hanjad, in grade 5? Oh my God. You have a cool teacher. Tell me, what was your design?
Like we went on هيك دراج وكل واحد جاب معه egg عملها بطريقة. أنا my egg بتذكر عملت البروجكت with my dad. We boiled the egg and
boiled? Are you allowed to boil it?
Tupperware وTupperware what's it called? Like the أنا 5 point shoes.
All right, I have connection issues. Okay, can you hear each other? Because I cannot hear you. I think you can. Can you hear me? Okay, I'm gonna put my video away for a moment. Can you hear me? Okay, so let me tell you what the project is about for the students who do not know. The project is for you to throw...
You can't hear us talk.
I can hear you glitching a bit. Okay, let me know at any moment if you cannot hear me. It has to be a raw egg, yes. And yeah, 1 second. And you have to throw the raw egg from a certain height that is constant for all the students. And Mia, I think, cheated with her dad because she boiled the egg, or probably she did not know the rules of the game because it has to be a raw egg. And unless your teacher doesn't know what the project is about, or probably your teacher decided to change the project. It has to be a raw egg, and you're supposed to protect it with a design. And for you to protect, because force, it's going on and off. I'm sorry for that. So let me try to write quickly because I don't want to lose you really, because probably I'm gonna lose you forever in a while. So you need a small f to protect the egg, and for you to have a small f, you need a small delta p or a big delta time or both. Okay, what is a small delta p? A small delta p, what's wrong? No internet connection? Okay, go try again, please. هلا بترجع الانترنت. I have internet. Sorry, Yara is here. She's asking for internet connection. So, like the house is gonna be on fire without internet connection. So back to you. How can I decrease delta P? By making the system go slower before collision. And this can be done with the parachute system. Okay, slow before collision, it's like P initial is small, because P final is gonna be 0 anyway. Whenever it collides with the floor, it's gonna stop. Now delta T, how can I increase delta T? It's not the time taken to reach the floor, it's the time during the collision. So to create a cushioning system, a sponge, anything that makes the collision, yani the time through which it's touching the floor, to be long. You see? Yeah, I know this is not super clear to you because I was interrupted many times. I'm gonna try to put my video on again. Let me know if you cannot hear me. Same thing with the airbag. Probably Mia, now that she has cheated with her dad on the project, probably Mia, you can explain to me how the airbag could be a safety precautions for you using the impulse momentum theorem. Can you try? Yes.
Using the Fermi, I don't know.
Yeah.
No.
So you want small force to protect your body, right? What does the airbag do? Does
Yes.
it change your delta P or delta T? So delta P is related to your speed, and delta P, for you to decrease it, you want small delta P, meaning you have to slow down before collision. And sometimes this is not possible.
Yes.
Yeah. What does the airbag do? Delta P or delta T?
Delta P.
It is actually delta T. So the airbag increases, yes, Dilla, that's true. The airbag increases the time of the impact. Instead of you stopping suddenly, you stop through some time. It's like a cushioning device, like a sponge, to increase the time through the collision. It's not delta P, because delta P has to do with your own speed before the car accident. So if you have a good reaction time, you will press on the brakes and slow down before the car accident. But let's say you don't have this, you don't have this luxury, you cannot do it because it was so quick. The only thing you can control is delta T by having an airbag. So the airbag will make your collision longer through time and the force smaller for safety. Okay? Now, if I need to discuss the graph, abrupt versus cushioned, can you tell me, Mia, which one has a greater time? The abrupt collision or the cushioned collision?
Of course, the cushioned.
So the cushioned, yes, because yesterday they were very confused. The cushion will give you more time and the abrupt will give you less time. And which one is safer?
Also cushioned.
Yes, because more time means less force, and which means it's safer. Okay, so safer. Now, if I compare both graphs, delta P is equal to F delta T, and F delta T is the area under the curve, right? Delta P is constant in both cases. I'm going to assume I will have two different car accidents, same initial speed, same final speed, which is 0, because car accident you need to stop. So delta P is the same for both cases. The more time, the less force. So more time, less force, right? Here you have less time, more force. However, the area is the same. So you either have a wider curve or a sharper curve. And yes, F and delta T are inversely proportional. Now tell me, which is safer, the wide curve or the sharper curve? Which is safer? Mia. Or anyone else, which is safer, a wide curve or a sharper curve? Or probably you cannot hear me.
A wide curve.
Yes, wide curve means...
Sharper.
All right, so wide curve means this curve. Let me change the color. This is a wide curve. Wide means bigger time and less force. Sharper means, let me use green. Sharper means very small time and very high force. To discuss safety, you have to look for the force. You need a small force, or you don't want a high curve, you want a low curve, because high curve means high force and it's not safe. Yes, less force is what you want for safety, because force is the one that is gonna hurt you. The Newton is the thing that is hurtful. Okay, so we have to look for something cushioned. Anyway, I'm discussing that because I know for a fact that it is there in your lab report. How do I go to the beginning of the document? Is it Command H? Let me try. What did I do? Okay, it was a wrong. Okay, let me go to the... When I was a kid, it was Control H. Now things has changed probably. Okay, what's that? How do I... Okay, I'm gonna scroll. I'm just gonna protect your eyes a bit from scrolling. Yes, so I wanted to go momentum and collision. Let's go over the lab report a bit. So this is a question you have to answer related to the egg drop. This is using the impulse momentum theorem and before doing the experiment. This is the experiment. And these are the questions you need to answer, and that's it. No plot, no data analysis in terms of error analysis. You only need to do percentage difference, compare describe, and that's it. Very easy, very short lab report, and talk a bit about cushioned and abrupt collisions and all that, and airbags. All that was in the presentation. You see, and I'm gonna save the presentation, send it to you edited. Any question? We're done.
Doctor?
Yeah.
So we don't have any errors in the lab report?
The only thing you need to do is percentage difference, and that's it. And I don't like this. And there's something called sources of errors to discuss. Watch the video, you can see it through the video.
Doctor, I have a question. Should we consider the error of the protractor or not, the angle?
As you can see, the angle is constant and it's not measured.
So we only have the error for the mass.
And if you want the error for V, since it's a digital measuring tool, because you read it as as digits on the screen from the smart tool, you can also take the error on V. So you can have the error on mass, the error on V, the error on area, and all of these are digital, so it's the last digit. If you want, you can calculate the error on P, the error on delta P, but this is optional. You can. It's not required though.
So what is required concerning the error?
You will be given the masses, the impulse, the V. You're required to do those calculations and this and answer the questions.
So we have to include the error on V and P.
I don't see plus or minus anywhere.
Oh, okay. So only for the mass.
Yes, this is the minimum requirement, definitely. And remember, that's a template. You can do anything you want. Add to it analysis, add to it a conclusion, anything you want, This is the minimum requirement. And I'm going to definitely grade you according to the minimum requirements. But if you would like to say something, or if you notice something that is worth of a certain explanation, please go ahead, okay? Remember, that's not a homework in the course. It's a lab report, and this is a template to follow, and you can do more if you want. I know usually students would want to do more when they do their own experiment. Now that everybody has the same results, you don't have things to discuss really. You don't have problems to discuss or issues, Usually students would like to write a conclusion when they have an issue happening and they want to talk about it. But now you are given some data that are somehow perfect, and there's not a lot of room for discussion, which I understand. But keep in mind that a lab report is a template, which is a minimum requirement to go beyond whenever you have ideas to discuss. Okay? Did I confuse you? Did I answer your question?
Yes, doctor. And so we don't have anything concerning the error on G or nothing?
Anyway, read the lab report and come back to me if you have questions.
Okay, thank you.
Okay, why ask me if it's all there? Okay. I will stop recording, but I'm not gonna leave you. I will stay if you have questions.